All right. Good evening, everyone. For those who are currently enrolled in the 203 TechBots course, you can see that we have quite a bit of a crowd tonight. And that is because this is an open course where we have a teacher today who is going to be talking about ChatGPT and why it's so unique, and then integrating it onto MIT App Inventor that all of you know so well. So I'm going to quickly share my screen to show you the slides for this very special lesson. So welcome aboard again to those who are familiar and those who sign up from afar through Eventbrite. Welcome. So just one second as I share my screen. I'm going to grab the slides really quick. And okay. Okay, can everyone give me a thumbs up in the chat if you can see this? Yes. Okay, perfect. Thank you for the confirmation. All right, so just starting off with some visuals. Again, welcome. You probably all saw this flyer and you kind of get a bullet point sense of what this open course is about. Step-by-step tutorials, getting ChatGPT accounted for, program with OpenAI Web API, as well as the two other points below it. Our lecturer today is Kevin Mung, who is a junior at MIT. And he's also in research and a developer on GPT. So what better way to learn from someone who is very well immersed in this topic? So there is a QR code in this flyer. It's going to direct you to a WeChat group. And I just want to give everyone 10 seconds to whip out their phones and scan this QR code so you can join that group to continue the conversation after today's fruitful discussion. And I think just to be more flexible, I'm gonna just control and I'm gonna drop in the chat a screenshot of this. Okay, it's restricted. All right, if anyone isn't able to scan at this point, I'll come back to this slide, but we will continue. So I guess a really quick introduction for me, the speaker, and you're only going to hear from me for the next like 30 seconds. But just very quickly, my name is Katsu. I currently am not a student like Kevin is, but I am currently a research associate under the Yale University School of Medicine. And you would expect us to be crushing up pills and pipetting some chemicals into a tube, but that's not the case. In fact, our lab is called the Play to Prevent Lab, and we create video games specifically for teens and young adults. And we partner with a lot of programmers who make our games come to life. So even though my job is not specific to coding, it's very hard to deny that it plays a big role in our lives now, and it's going to play an even bigger role in the future. So you are only taking the steps forward by joining this hour or so today to learn more about it. But yeah, that's pretty much my background, my project, and it's really cool. So hopefully you guys can play our video games at your schools one day. Okay, so I think this is about the time I segue and pass the baton to Kevin, but just as an opening to make that title solidified here, this is the 203 TechBots open course, GPT and Web API. And a little introduction of Kevin is that, first of all, he's well immersed in this topic, but he is also very stacked in his experience with, teaching other students about MIT App Inventor. And he's currently creating a startup in the entrepreneurial area. So very enthusiastic speaker, and he will show that to you as I pass it to him right now. So Kevin, please take it away.
Sure. Hello. Hi, nice to meet you all. My name is Kevin. And I am really excited to be here. It's going to be a lot of fun. So today we'll be talking about ChatGPT and how it works, why it's so important. And so here's like a general structure of what we're going to do today. We are first going to play with ChatGPT to understand like what it is, all the funny things that it can do, all the useful things it can do. We're going to talk a little bit about the internal workings of GPT. So like a very basic first principles kind of what does GPT do and how does it do it? This is hopefully accessible to people who haven't even touched AI before. And then we're going to see how we can use ChatGPT to enhance our mobile applications. So people who are from the class or the TechBots class, you'll know what MIT App Inventor is, but for people who don't, MIT App Inventor is this amazing programming environment that lets you write really quite complicated mobile applications, even though it's quite simple. Like it's simply a block-based system. It's very elegant and it allows you to build very powerful apps within literally days of learning how to program. You can start building applications. So that's the roadmap. So we're going to talk about what ChatGPT is, what it does, how it works, and then how to integrate it into your mobile apps. And mobile apps obviously are great. They're really fun, and they can also be very helpful to you in case you're interested in participating in hackathons or competitions or science fairs or stuff like that. So yeah, at any point, feel free to throw questions into the chat. For the people that are attending, it would make me very happy to see all of your faces, and that way I can also gauge how well you're doing, kind of. So if you are capable, please turn your camera on, and hopefully it'll liven this room up, because right now I'm just talking to a bunch of squares. So yeah, that's the plan. All right. So before we get started, let's do a little poll. How many people have played with ChatGPT? At this point, it might be easier to count the number of people who have not. Oh, okay. So some people have played with it. Some people have gaslit it. That's a very fun activity. Okay, so a lot of people have played with it. For people who haven't, we're just going to quickly go over like what it does, and I'll show a demo. And then so hopefully that'll give you intuition for what it does. And then this will be really quick. Then we'll talk a little bit about how it works under the hood. And then we'll talk about how you can use it in your apps. So yeah, a lot of people have been doing some pretty funny things with it. So we'll also talk about the maybe higher level societal questions that are raised by how ChatGPT works.
Catherine, can you stop sharing? Maybe just let Kevin do it, right? Kevin,
Sure.
do you want a slide or what?
No, I'm just gonna share my screen.
Okay, great.
Cool. Yes. So yes, I'm seeing a lot of very cool and very fun things that people are doing with ChatGPT in the Zoom chat. Is that a typo? I told it to write a song in Javanese, like Java, the programming language, because it probably could do that. I have no, oh, it's a language. Oh, okay, cool. Nice. I didn't know that. Nice. Yeah, so basically ChatGPT is this like chatbot thing, and it seems to be able to answer your questions. So you know, you can ask it very simple things like, what team does LeBron James play for? You can hit enter and then it'll kind of tell you that he played for the Los Angeles Lakers. You can say what constellation, you know, what are some stars that you can see in the night sky? You can ask it a question and then it says you can see Sirius. And it says it's located in this constellation, that constellation. But if it didn't actually say that, you can actually just copy this and say what constellation is part of, and you can ask a question. So, so Sophie raises a good question. It's a more direct Google. That's a very good observation. So it can be used to replace a lot of the things that you might ask Google. But there's something you need to be very careful about, which is ChatGPT is quite unreliable. And to understand this, you'll have to understand how it works. And so I'll talk a little bit about that in a moment, but all you need to keep in mind is that the things that it generates may not be true, and it could just be making stuff up. And that's an active research question in language modeling, which is how can you get language models which are incredible at like understanding what you want to ask, but they're not super great at not making things up. They'll often make things up. And so so these are the most basic questions you could ask it. These are just like factual queries, but you can ask it to be creative. Like write a rap about doing well in school or something like that. And, you know, it's got rhyming, kind of. Excel and Bell rhyme, way to go, you know, shine, fine. So it kind of understands that, and it's got like all the verses, all the choruses. You can ask it to write a limerick about taking over the world, and hopefully it'll not do that. Okay, never mind. This is great. So it's a limerick. So yes, you know, you can do a bunch of crazy things, like, and there are nerdy things you can do with it too. Like you can ask it to do what's called zero-shot learning. Basically, ChatGPT, you can treat it as something that understands the world very well. And so you can just ask it to do classification on your data sets. So you could say, like, I have here, you can give it more advanced queries. You can say, here's an Amazon review. And the review is like, I really loved this Kindle, but it's way too expensive for me and didn't work all the time. Answer the following question. Did the user find the Kindle hard to use? And then it'll kind of look at that. And then it says there's no indication that the user found it hard to use because the user loved it, but the other issues that it mentioned, like being way too expensive and didn't work all the time, have nothing to do with the fact that it was hard to use. And so, yeah, you know, Amanda makes a good point. Like if you ask it a stats-free response question, it'll give you the wrong answer a lot of the times. If you ask it to add like numbers, it'll often give you the wrong answer, although I don't know if this one is actually correct. Oh, 2351657. This one actually turns out to be correct. But if you give it word problems, sometimes it will trip over itself. And there are all these different tricks that OpenAI is using to get this thing to work better. But basically, you get the point. It can talk to you. And so the natural question to ask is, well, how is it doing behind the scenes, right? Because when you are working with a chatbot, one of the main questions is, can I trust this chatbot? Is it going to make stuff up? And, you know, is it reliable? And so to understand how you, to understand why it may or may not be unreliable, you need to understand how it works. So there's a comment in the chat about it being able to solve algebra word problems. This is true when the word problems are very simple, but ChatGPT will occasionally get them wrong. There's no indication that ChatGPT is not confident about its answer, even when it is wrong. And it's very confident when it's wrong. So the point is, like, why are people saying that ChatGPT is unreliable? And to do that, we need to understand how it works. So let's do that. I'm going to share my screen and let's talk through what ChatGPT actually is. So ChatGPT is something that we call, it's built on this neural network architecture called a transformer. Now, give me 1 second so that I can actually pull up the chat while I have my screen shown. But in the meantime, does anyone have any questions about like how ChatGPT works or like what it can do or stuff like that? Feel free to ask any questions. And then once I can pull up the meeting on my phone, we can continue and we can talk about how it works behind the scenes. No questions? What about predicting? That's a great question. Oh, so would you mind explaining a little bit more what that means? Do you think it has the capabilities to replace artists in art creation? Probably. You know, it's funny, like Yes, I mean, you can see that it's writing limericks and raps, and it's that is a form of art. And so one could claim that it could generate things that we perceive as art. But really, if you think about it, the point of art is to express a story or an emotion that someone experienced. Like that's the whole point. It's to document it's basically to document the human experience. And so art becomes a little bit less meaningful when it's generated by a computer. That doesn't make it any less enjoyable. There's a distinction. It's less meaningful, but it's not any less enjoyable. So depending on how you define art yourself, you can kind of decide for yourself whether you consider the things that that it produces as considered to be art. Sophie, can it do inference and predict future events? This is a tough question to answer. The answer is basically that it's not going to be reliable. Sometimes it might guess it right, but it's kind of just pure chance. Okay, anyways, my my thing is up. So now let's talk about transformers. So ChatGPT is a neural network. Has anyone not heard of what a neural network is? Does anyone not know what machine learning is? Let's start there. Can someone define machine learning for me in the chat, or maybe just unmute yourself? I am trying to get a gauge for where we are as a group in terms of understanding and fundamentals. Okay, so an AI uses data and trains itself to know more about it. That's a great initial definition of machine learning. So ChatGPT is a machine learning model. It is a machine learning model. And the point of a machine learning model is to learn a set of rules that maps an input to an output. Like that's all machine learning is. So in the case of ChatGPT, the input might be like a user instruction. Please write me a rap about doing really poorly in school, about bombing my test. And then the output would be something like, well, here's the rap, or here's the limerick. And so in very simple cases, you might have heard of classification. Like the canonical example is if you point a camera at a dog or a cat, a machine learning model should be able to tell whether you're looking at a dog or a cat. So the input would be an image of the dog or the cat, and then the output would be whether it is a dog or a cat. So this is what machine learning is. And furthermore, there's this thing called deep learning. Deep learning is a subset of machine learning, or in other words, it's a class of machine learning models that are extremely powerful. And they're powered by things that we call neural networks. Neural networks are, and the terminology is a little bit contentious, but basically the point is that neural networks are these brain-inspired structures, computation structures. In essence, all of machine learning is about math. It's about fitting parameters to a model. But the point of neural networks is that they're organized in a way that's somewhat kind of, it's debatable, but kind of reminiscent of how the brain works. So the way neural networks are organized, you have a bunch of neurons and they're connected to a bunch of other neurons in like super complicated ways. You have neurons, just like that. And when you have neurons, you have an input here, and it goes through the model through multiple layers of this neural network. So you can imagine there are multiple layers here where they're all like super connected to each other. And this is kind of reminiscent of how your brain is connected. Your brain is kind of just a bunch of nodes, neurons connected together. And so you have this like big structure of neurons firing and talking to each other and things like that. The point is that neural networks are very powerful when you have lots of data, and they're able to do machine learning very well on domains where you have a lot of data. So they are very good for text and images. Those are the ones that are they're like extremely popular for. And so things like I just mentioned, classifying whether a dog or like a picture is a dog or a cat, it's a classic machine learning task, but deep learning is really good at it. And So any questions so far? We good? It's a pretty simple setup here. So the point of machine learning is to map inputs X to outputs Y. And this is just a special type of machine learning model. Pretty straightforward, right? Cool. I don't see any questions. Make sure not to DM me. Make sure to send your questions in the big chat so that I can actually see them. Cool. So these are the fundamentals. What does this have to do with ChatGPT? Well, ChatGPT is a transformer. And I can show you a diagram of a transformer. This is what a transformer looks like in the paper that first introduced them. You don't have to understand how it works. In fact, the only thing that you need to understand is that it has an input and an output, but I just wanted to show it to you for completeness in case you're curious. This is what it is. You kind of pass some inputs in and then it'll get you some outputs out. Like that's literally all you have to know about the transformer. But the point is that it's a specific type of deep learning model. Within every one of these little boxes is a bunch of neurons that's connected to the next layer of neurons and so on and so forth. So an extremely powerful model that has seen a lot of success in the text domain. So a transformer is a deep learning model with success in the text domain. What does it actually do? Oh, I think there's a question actually. What is the difference between AI and ML? Is ML a subset of AI or are they the same? You are absolutely correct. ML is a subset of AI. So AI is a pretty loaded term because, I mean, as it suggests, it's about artificial intelligence. Well, then you have to say, well, what is intelligence? And every single person that you ask will have a different definition of intelligence. In fact, try asking yourself. It's a really difficult term to define because it's very hard to approach from first principles. And so usually the way that people define intelligence is through characteristics of the objects that have that property, if that makes any sense. Like you don't define intelligence, when you define intelligence, a lot of people tend to say, if you are intelligent, then you should be able to do X, Y, Z. That's not actually a first principles definition. So it's very arguable and it's very easy to disagree about what intelligence is. But kind of the point of artificial intelligence, vaguely, is to be able to interact with the world and learn from it. That's kind of what intelligence is about when you think about humans. And so it's a very vague term. Like artificial intelligence could totally not involve machine learning. In fact, you could build a chess engine that you could claim is artificially intelligent because it can look at a chessboard. And without any deep learning, without any machine learning, it can simply enumerate what's called a game tree, or like it can do a depth first search. And it can basically imagine, it's like Dr. Strange. You can imagine all the million possibilities that your opponent could play, and then you could choose the best one in expectation or something. That involves no machine learning, but you could claim that it's artificial intelligence because it's about observing data about the chessboard right now and then making intelligent decisions that make you win much more than average. So there's so many different, AI is a very rich field. It's very diverse. There's games is part of AI, reinforcement learning, exploration, decision-making with uncertainty, Markov decision processes, machine learning, everything is part of AI. Like fundamentally, you might even argue that all of computing is AI. So yes, ML is a subset of AI. AI is pretty big. So the transformer is a deep learning model that has seen a lot of success in the text domain. And one of the first things that it was useful for was to do text classification. So if I had like an Amazon review, I have, I hate the iPhone. And if you've ever like done basic research in NLP, you might have been given a whole data set of these things, and your task is to classify whether this is a positive or a negative review. And then the other one could be, I love using my Apple Watch. And the question is this a positive or a negative review? Like this one would be negative, and this one would be positive. And so what you could do is take something like this. You could take the input here and you could put it into a transformer. And this is a neural network. So it kind of looks something like this. You've got a bunch of neurons that are connected to each other and stuff like that. And then so you take it in and then you spit something out. And what you spit out is a score. A score. The score is between 0 and 1, and it indicates how positive the review is. And so if you think about it, you actually have to, this transformer right here, this transformer has to be really good at understanding language, because there's so much like complicated stuff that could happen when you're doing sentiment classification. Like you could totally just have double negatives. I don't hate the iPhone. That means that you actually are relatively positive about it. And so you know, you can't do a simple keyword match. You can't simply just write a stupid rule that says if the word hate is in the review, then you know, then it's a negative review. Like that doesn't always work. So basically the transformer is able to understand language and then spit out a score. So we're almost at the final step. So what does ChatGPT actually do? Well, this kind of sentiment classification is not interesting to us, right? Because what we want is for the model to talk back to us. We don't care whether something is negative or positive. We don't care about classification. We want it to spit out more words. And so naturally, what is the extension? Well, instead of trying to extract a score from it, you modify the transformer just a little bit so that instead of a score, you get something else out. Does anyone want to wager a wild guess as to what comes out? If we're trying to generate like a response to an input, what do you want the transformer to predict? And again, if you have any ideas, please put them in the chat and in the main chat. Yeah, exactly. Aaron's totally correct. We want this transformer to output human language. And the way that we do that is called autoregressively. And so a transformer will read your piece of text, like I hate the iPhone, and then it'll spit out more words. So actually the output of a transformer is to output just one word, one new word. So the point is, like, if you have a sequence of words like x1, x2, all the way to xn, and you feed this into the model, the point of the model is to learn a mapping that can take x1 through xn and then spit out x1, x2, or like, oh no, you don't spit those out. The point is to spit out xn plus 1. So now you have a coherent sequence from x1 all the way to xn plus 1. And the powerful thing about this paradigm is that you can repeat this operation an infinite number of times in principle. So if you've generated the xn plus 1th token, you can then do this again and say, okay, well, now I'm just going to feed you x1, x2, all the way to xn, and then take n plus 1 and then pass it back into the transformer. And you're going to spit out xn plus 2. So then you can actually just do this a heck ton of times. You can do this just once, you can do it twice, you can do it 100 times. And if you do it 100 times, you will have generated 100 different tokens that come after the token. And as stupid as it seems, this is exactly how ChatGPT generates its responses. It is trained to predict the next token in a text sequence. And just from this really, really simple task, it's dead simple, a teenager could have come up with this training objective. It turns out that if you train it on a lot of data, this gives you incredible emergent properties, like what we just observed in ChatGPT, where you ask it a question and it learns to reply in a way that is pleasing to the user. And all it does is it reads your response and then it generates one new word at a time. So, for example, if I told it to, if I asked it a question, what team does LeBron James play for? This is sort of my input, and then I send it to ChatGPT. What actually happens? It generates one token. It generates he. Okay, so then I have this. Then let's copy this over. Then I got to do this again. And so now I take this and I append it here. Notice that this is just moved all the way here. And then this, when you put it into ChatGPT, I'll just abbreviate it GPT. What does it give you? It gives you plays. Okay, hopefully you're kind of getting the point now, because we're going to do this again. We're going to say, okay, well, what do we currently have in our sequence? He plays. And then what if you feed this into GPT? And then you can say for, and then you keep doing this. You just keep doing this, and it'll generate he plays for the LA Lakers. You can see that this generation paradigm, what we've just described here, is stupid simple. There's really nothing more to it. Obviously, like, there are a lot of details, but the high level idea, there's nothing more. Like, this is how ChatGPT works. GPT works like this. It's simple. Very simple. That's literally all it is. It's reading the context and it's predicting what should come next. And after you predict what comes next, then you feed it back into the model, and then you do it again, you do it again, you do it again, until you get a coherent response. So Li Jian has a good question. How hard would this be to code? Well, it depends on how good you are at coding. For somebody who's experienced, you could from scratch, but you have to use an auto differentiation library, which is what's standard for deep learning. But if you have like a library that does most of like the heavy work, I could implement this, for example, in about 15 minutes. The code that implements the GPT architecture and does the training, it'll take me about 15 to 30 minutes. I would consider that pretty fast, but it's really not that complicated. Like, you can write an implementation of GPT in like 200 lines of Python. It's not that complicated. And so I really hope that this demystifies a lot of what's going on. Now, I mentioned earlier that we're going to talk about why understanding this model in this frame is important. And it actually is extremely important. But before that, let me answer some questions. How does it know what the next word is? Like, how does it know if the next word is Lakers? That's an amazing question, Kellen. So the point is that I've abstracted away a lot of the details. In fact, there's this big glaring hole in my explanation, which is what the heck is actually going on in these boxes? Because that's where the secret sauce is, right? That's where the prediction is actually happening. I've described how the predictions are made in a structural way, but I haven't explained what actually goes on inside this box. So I will explain that later. Will there be a recording on YouTube? I guess so. I don't actually know. Probably. Cool. All right. So does anyone have any further questions, or does this make sense to most people? If it does, please, like, if it doesn't, please let me know. All right. Yeah, you guys are doing well. So I guess the next step is to understand why this is important. And we're going to talk a little bit about probability, but not too much. So the way that this works, so now that we understand at a high level what is going on when you generate a piece of text, let's zoom in and let's use some variables so that we don't have to keep writing out this annoying example. Let's call X our input. And let's make it smaller. Let's call X our input, and we're feeding it into ChatGPT, and we get an output, right? And this output is this is supposed to be the text prompt, and this Right here is supposed to be the output word. I've actually lied to you. This is not what comes out of the model. What comes out of a model is not y. It's something that we call P of y. P indicates that it's a probability distribution. Does anyone not know what a probability distribution is? Or like, I'm trying to understand where everyone is in the class. And so can we like, maybe like just type into the chat, type like a yes, no, kind of, in terms of like whether you know what a probability distribution is. Okay, awesome. So a lot of no's, some yeses, some kind ofs. I'll make it really simple. There's not a lot you have to understand about probability distributions to have an intuition for what's going on. Okay, great. So let's talk over it. So in very simple layman terms, a probability distribution indicates how likely a certain set of outcomes is. Like when you check your weather app, when it says it's 70% likely to rain, it means it's kind of hard to describe this, or like it's okay, weather is a bad example because it's not actually a probability and it's like estimated. Anyways, when you flip a coin, the probability that it comes up heads is 50%. And the probability that it comes up tails is also 50%. And what that means is that if you run this like, the implication of the probability is that if you do this independently like 100 times, then 50 of these in expectation will be heads and 50 in expectation will be tails. And so it's telling you if you were to perform a certain action a bunch of times, what outcomes are most likely. And essentially it can, so probability is a really complicated topic, and I'm trying to find a good way to explain it properly without being incorrect. So I think all that you have to know for the intuitive interpretation of probabilities is that if something is more likely, then it is better. Like that's the super simple way of putting it. You want things that are more likely. So if I give you, okay, actually, okay, I'll explain it this way. So I have a sentence. Okay, so the students sat down and opened their blank. There is a blank here, and you need to fill in the blank. If this is all the information that you have, what would you fill in the blank? Does someone want to offer like a guess, or like, it's not even a guess, it's just, what do you think should go in here? Exactly, books. So it could be books. What else could they open? They could open their lunch boxes. They could open their computers. Exactly. What do you think of the proposition they opened their Nintendo DSs, or they opened their piano, or they opened their Apple, or they opened their stuffed animal? What if it was like crime? Do these make sense at all? Yeah, they opened their airport. Like, what the heck does that even mean, right? So there are certain things that are more reasonable. And the way that we quantify reasonability is with probability. And so there's actually another distinction between empirical probability in terms of statistical probability versus actual probability. So this is getting a little bit sidetracked. But the point is that if you scanned through all the things that people have ever uttered in the entirety of human existence, I would wager that very few of those instances started with the students sat down and opened their airport. Like, no one ever says that. If you went to Wikipedia and you looked for, or if you went to every single thing that anyone has ever said in the world, just imagine all the things people have said in human history. And if they started their sentence with these students sat down and opened there, how many times would it have been airport? Not many times. So what I just described to you is the empirical estimate of a probability by sampling data. So if you can imagine, and if you can imagine like things that you could read on the internet, a process of the students sitting down and opening something, very few times would they open their apple, or very few times would you see the sentence that said the students sat down and opened their monkey. Like this just never happens. And so the data or your personal experience, basically what people perceive to be fluent and sensical text, would say that the empirical probability of this word being monkey is extremely, extremely low. Like no one ever does that. No one sits down and opens their monkey. Like, what does that even mean? And so what we can do is we can say, well, let's try to model this empirical probability. These are extremely likely. So if you just went to every single thing that a person has said and then gave it the prefix, the student sat down and opened there, I feel like a lot of the time it would have been books, it would have been lunchboxes, it would have been computers. And so in like all of human history and all the things people said in human history, books, lunchboxes, and computers have had a high empirical probability because it's reasonable. Like people have said things like this before, and people have never said and opened their crime or stuffed animal or monkey or airport. So the point is that GPT actually models an empirical probability distribution over text. That's what it does. And so for every single one of these, you could assign like a sort of arbitrary number to describe its probability. Let's say that out of all human text, like when you saw this prefix, books came up 30% of the time, lunchboxes came up 20% of the time, computers came up 10% of the time. And then you can imagine, like in the English language, there are only so many words, like there's a finite number of words, and everything else, all the way, like every other English word had really low probability and they added up somehow to 0.4. So all of these have really, really small probability and they add up to 0.4. Why do they have to add up to 0.4? Because probability distributions have to add up to 1. Like if you look at all the things that could complete the sentence and you add all their probabilities up, they have to add up to 1. It's just a fact of probability. And so yeah. Now, if you have a probability distribution and you want to mimic it, you would sample. So an example of this is if I'm flipping coins and the probability of heads is 0.5 and the probability of tails is 0.5, how would you simulate a coin flip? You would simply choose a random number between 0 and 1, and then if it's less than 0.5, assign it heads, and if it's greater than 0.5, assign it tails, right? So you sample from this probability distribution to model the process that it would take in the real world. And so if you wanted to generate a continuation of this sentence, you could say, well, let me just sample. I have this probability distribution over the next word, and books is super likely. It's probably a good choice. Lunchboxes is a little bit less likely, but it's still probably a good choice. Computers is kind of unlikely, but it's probably a good choice. But imagine like you have 0.001 down here, and these are really, really unlikely, probably a bad choice. So let's say that, you know, I have this like super cool coin that can just tell me, a super cool weighted coin that can tell me which of these options I should choose. And let's say that we actually, you know, we choose books, we choose the maximum likelihood option. And so, yeah, then we're happy. We chose a word. And so the point about ChatGPT not giving you an output word, but rather giving you a distribution over words, the point is that ChatGPT models a probability distribution over text. It says, if I have an input, what is a reasonable thing that I could say next? Like, if you asked what team LeBron James, a basketball player, plays for, you would never really expect to answer with a football team. Like that should have 0 probability because it makes 0 sense. You should not answer with a fruit because a fruit is not an NBA team. Like that makes absolutely no sense. So basically, if you ask what team does LeBron James play for, it's probably going to be the probability distribution will probably look something like, you have 30 NBA teams. There's the Lakers, the Mavs, the Celtics, and all the teams. There are 30 NBA teams. And maybe each of these has pretty high probability, right? Because you asked what team does he play for, and he's a basketball player. And so all the NBA teams should have relatively high probability. Let's say that they each have like, I don't know, 0.05. They have a 5% probability or something. And then everything else that's not an NBA team should have really low probability because it's not an NBA team. Like, it doesn't make any sense. And then if the model is really smart, it'll assign an extremely high probability to Los Angeles Lakers. Maybe it pushes the probability up to 0.6. And then the Mavs would be 0.05, Celtics 0.01, blah, 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 blah. And because the Lakers is the highest probability, then it's most likely to be chosen. And then so ChatGPT will spit out the Lakers if the probability is very high. So does anyone see any problems with this approach? What do you mean smart when describing a GPT? Okay, that it can answer your question properly. It's kind of hard to describe what it means for a machine learning model to be smart, but basically it generally means like it does what you want. Yes, okay, you guys are awesome. There is still some probability that it will be wrong. It might choose other options. Spot on, guys. That's perfect. 5% probability is really not that low if you think about it. If you do something 20 times and it happens once, then it will have a 5% probability. If you got in your car 20 times and it crashed once, would you be happy? The answer is probably no, right? You drive more than 20 times every week, maybe. And if 1 out of every 20 times you got in a car and it crashed, you'd be extremely unhappy. Well, guess what happens? When GPT samples the next word, it samples from this probability distribution, and the incorrect answer will be sampled 0.5% of the time. And so once in a blue moon, if you ask what team does LeBron James play for, if the probability distribution is not super confident that it's the Lakers or the correct answer, it won't say that he plays for the Lakers. It'll say that he plays for the Mavs. This occurs with a 5% probability. And so when you want a chatbot to be good, 5% is actually a pretty bad failure rate. Because imagine if you asked Google 20 questions and then it gave you just randomly a wrong answer every 1 out of every 20 times. That's pretty bad, right? And so finally, you're starting to understand why ChatGPT is not seen as reliable. Because the process of generating text with ChatGPT is inherently probabilistic. You don't know what's going to happen. You know that with a high probability, the correct answer will be chosen, but there is an extremely non-zero probability that the wrong answer will be chosen. In this case, what is the probability? There's a 40% chance that ChatGPT actually chooses the wrong answer because of the way that this probability distribution is structured. All right, you might ask then, well, why don't you just learn a better probability distribution? Because this is stupid. Why is it 0.6? We know that it is the Lakers with full confidence. So shouldn't this just be 1 and everything else should just be 0? Why don't we just do that, right? The answer is that it's hard to remember everything in the world. If you think about the amount of information that is in the world, it is incredibly insane. And ChatGPT already does a good job at compressing all that information into a small amount of parameters, but it can't remember everything. It can't be 100% perfect at memorizing everything. There's just not enough information capacity to do that. And so you can train it to really remember the fact that he is on the Lakers super, super well. But if you do that, there's a trade-off, which is maybe ChatGPT won't be as good as answering other types of queries. So this idea that it's probabilistic and that probabilities can be imperfect and you can't seem to remember everything perfectly is a problem. And so that's why people say that ChatGPT is not very reliable. And it's true, because when it generates answers to your questions or when it does things for you, it does probabilistic sampling. And so there's a chance that it gives you some totally wrong answer. What this is really great for, though, is for creativity, because creativity is sort of like taking things and adding your own twist to it. And so ChatGPT could generate like a fan fiction about what happened, what would be if LeBron James actually played for the Mavs. And that's actually why ChatGPT is so creative. It's because it's probabilistic. It can just come up with some weird, wacky stuff and just kind of run with it. And it's very good at generating fluent text. I mean, it's very good to say, if I have a proposition, what should come after the proposition? Probably like a noun or something. So it's got all these rules encoded in these probability distributions. And the whole point of the GPT model is to learn this probability distribution. So you have a neural network, and the sole task of the neural network is to say, given an input sentence, what's the probability over the next word? And then given the probabilities, you just sample a random one, of course, weighted by the probabilities. All right, so let's answer some questions. If LeBron James just moves from the Cavs, he just moved from the Cavs to the Lakers, what happens? This is another excellent question. I love it, because for a long time, ChatGPT was only trained on data where LeBron James was on the Cavaliers. And so for a long time, GPT actually thought that LeBron was still on the Cavs when he was in fact on the Lakers. And so the problem with GPT is that you have to retrain it on new data periodically, or it just won't know what's happening in the world. And so, yeah, that's another problem with GPT. If you go to the uh-oh, my mouse is gone. No, I'm crying. What? Okay, if you go here, you can actually see an evidence of this. As of my knowledge cutoff date of September 2021, LeBron James played for the Lakers. So I can actually ask, because I know that someone recently got traded. If you're paying attention to the NBA, Kyrie Irving just got traded to the Dallas Mavericks. And if you ask what team Kyrie Irving plays for, he played for the Brooklyn Nets because he was traded in 2023. And so what the point is that the data that ChatGPT was trained on did not have data that reflected that Kyrie was on the Mavs. And so the probability distribution looked extremely biased in favor of Brooklyn. And that's a problem. Like, because ChatGPT is this really hard to train probabilistic model, you need to be very careful about trusting it. And in fact, that's what my research is about. My research is about understanding how GPT stores facts. And when players change teams or when new politicians get elected, the point is that you should be able to very specifically target the parameters in the neural network that GPT uses to model this probability distribution. And you should be able to change things instantly instead of having to retrain. That's kind of what I'm working on. So let's see. All right, you guys are doing really well. I love this. What is generative pre-trained transformer? That's GPT. That's what GPT actually stands for. So generative pre-trained transformer. What would happen if GPT is trained on data that might be incorrect or is misconceived by the public? This is another big problem. GPT was trained on things like, I mean, the internet is such a weird place, right? And anyone can say whatever the heck they want. And that's not always good, because ChatGPT, if you're not careful, ChatGPT will regurgitate conspiracy theories to you. There's like, okay, we're on stream, so I'm not going to say this, but like, there are a lot of ways in which you can get ChatGPT to say a lot of weird stuff that's not great. And it's because ChatGPT was trained on the internet. People can say whatever they want on the internet. It could be true, it could be false, it could be civil, it could be very, very non-civil. And so GPT kind of learns that. It learns the probability distributions over how people use language. And that comes a lot, obviously, with a lot of good things, but also simultaneously a lot of bad things. Can ChatGPT say private, controversial, or classified stuff? Indeed, it can. If you give it access to documents like health records, It'll memorize, it'll encode in this probability distribution your personal health details. If you ask it about, if your medical details got leaked, if your credit card details got leaked, if your address, your phone number, your email got leaked, ChatGPT could actually know who you are. And so the data that goes into ChatGPT to train this probability distribution it's a hot point of contention because there are privacy concerns. How does it know that the Lakers have a higher probability than the rest of the NBA teams? Excellent question. This is achieved through training. So training is what we call an optimization procedure. So say that you have a piece of text. LeBron plays for the Lakers. And what you can do is you can chunk this piece of text. This part is your X and this part is your Y. So now you say, well, let me take my X, let me feed it into chat, or let me just call it GPT. I feed it into GPT and it produces a Y hat. Y hat is the prediction. When ChatGPT is first, imagine like when a baby is born, it doesn't really know anything. When ChatGPT is born, it doesn't really know anything. And so GPT might generate like a total BS answer. Like it'll just say, what team does LeBron James play for? He plays for the Grape. ChatGPT just predicts Grape. And you'll look at that and go like, that makes absolutely no sense at all. And the way that you can quantify it making no sense to you, you can say, what is the difference between the probability distribution of Grape versus what I want? So imagine on the x-axis is all the possible words in the English dictionary. So it's like a word, apple, grape, and there are like 50,000 things on this list. Somewhere, Lakers is in this list, and the target probability distribution is right here. So you want, and this is 1 and this is 0. So you want the probability of Lakers to be 1, and then the probability of everything else to be 0. This is your ideal case, target case. This is your ideal target case. Well, what did my stupid model just tell me? It said that LeBron James plays for the Grape. Makes absolutely no sense. And if you look at the probability distribution, it looks something like this. This is Grape. So this is no longer the ideal target. This is like the prediction. And so what you'll realize is that these two probability distributions look extremely different. It's here versus here. This is a big, big no-no. Like you're not happy. And so what you can do is you can take the difference between these probability distributions. You can take a distance between the probability of over y hat and probability over y. You can take a distance and then you can call a minimize. So the goal is to minimize with respect to GPT the distance. This is what we call an optimization objective. And the point is that if you minimize this value, you minimize the difference between this distribution and this distribution, and then you average this, or in mathematical terms, you call this like you minimize the expected value of this quantity. You can get good results. Basically, if you have a bunch of text and you ask it to predict the next word and it does really bad, but then you apply an optimization algorithm against this objective, it'll minimize the difference between the predicted distribution and your actual distribution. Then it'll become really good, right? If you train it on millions and billions of pieces of text, then what's stopping it from getting really good? Cool. Anyways, hopefully that explains how the probability distribution is actually modified and made better. Cool. All right, any questions? I think this is about as technically complicated as it's going to get. Soon enough, we'll be back to just programming, which is significantly less complicated. Any questions about what we talked about? So I'll do a little recap and then we'll start coding. Coding is relaxing. This stuff is not relaxing. It's kind of hard to understand. So let's do a recap. Basically, ChatGPT is a machine learning model that can map inputs to outputs. In this case, when you do ChatGPT, your inputs are just like prompts. Your outputs are generating text. You want to map an input piece of text to an output piece of text. Now, deep learning uses what we call neural networks, and they're super powerful. They're very good for text and images. They're a special type of machine learning model. Then there's the transformer. It's especially good for text. And you can use it to do all these like cool classification things. But what we actually want is for the transformer to be able to say, well, given an input, can I predict the next word that comes in this sequence? Given this new input, can I output this new word in the sequence? And you do this in what we call an autoregressive manner. Autoregressive. If you ever take a statistics or an inference class or a probability class, this term will come up, autoregressive. But basically, your transformer is able to like predict the next word really well. And so the concrete example that we used was, well, what team does LeBron James play for? And then the next prediction is he, and then you stick this back into the input, and then the next prediction is plays, and then you keep going until it generates he plays for the LA Lakers. Now, we discussed furthermore, how does this actually work? How is it generating the next word? And so we talked about empirical probability distributions. The goal of GPT is to model a distribution of text, like what is a reasonable piece of text and what is not a reasonable piece of text. And so when you say reasonable, like things aren't always like, you have to like make the space continuous. And so we use probabilities. And so we talked about how when you answer a question, the probabilities could be pretty diffuse. Like even though the correct answer has the highest probability, the incorrect answers have non-zero probability. So in this case, with 5% chance, you're going to answer the wrong, you're going to answer incorrectly. And this probabilistic nature of GPT is exactly why it cannot be trusted as a search engine. Because it models things probabilistically, it has a high chance of just doing something totally wacky and making stuff up. Not cool. But it also makes it super great for creativity, and it's got all, there are these incredible emergent capabilities where you can just ask it to do stuff for you and it just does it for you. And then finally, we talked a little bit about the way that they're trained. You basically take a piece of text and you kind of cut it into two pieces, the input and the output. And then you pass it into the model. And then initially the model is really stupid. It gives you the wrong answer. And then you apply this optimization objective that will make the model better. And so the probability distributions are better. Cool. Will ChatGPT support images and videos eventually? I know that OpenAI is working on multimodal models, which means that it'll support images and text, images and video soon. So yeah, it's pretty exciting. OpenAI is a very good organization for engineering. And so, yeah, I have no doubt that they'll figure it out. Are there other popular transformers besides GPT? Not really. The most popular one right now is GPT, but there are other popular ones for different tasks. There's BERT, which is mainly used for classification. And then BERT has a bunch of variants, like people put stuff, they like modify BERT a little bit and they publish a new paper. There's BERT and there's GPT. That's pretty much it. Like all of these like different transformer variations are all extremely similar. And it's kind of just a matter of branding. Cool. How can I inherit ChatGPT's capabilities and train it with additional data? Excellent question. So this process is called fine-tuning. It's basically where during this optimization procedure, GPT is not actually born as a dumb baby. It's born as itself, and then you can feed it more data. You can feed it more XY pairs that you define, and then so it'll inherit the knowledge that it already had, but then you can add new knowledge by minimizing this quantity on your custom data. It's called fine-tuning. It's basically just the same idea of training, except you initialize GPT with your with the smart model instead of the dumb one. Cool. Any other questions before we start programming? So will AI get better at probability giving the right answer, or will AI always be based on probability? Yeah, that's a pretty interesting question. My guess is that, so like the nice thing about probability is that it's you can map it to a continuous space, and it's important that it's continuous because you need to be able to differentiate it. You need to, okay, basically the point is that if you want to optimize this objective, you need to use this algorithm called gradient descent. And gradient descent has some requirements on the functions that it can optimize. One of the requirements is that it has to be continuous. It can't just be discrete. It can't be ones and zeros. It has to be numbers. And so, and so probability is a really natural way of modeling confidence in continuous space. It's probably like, if you don't want to use probabilities, then you'll have to find a new optimization algorithm. And gradient descent is really the only optimization algorithm that's really worked well for deep learning. There are other ones that kind of work well, but not really. They're not popular. So yeah, I mean, the more you train these models and the more powerful they get, the better they'll be at modeling probability distributions really well. But yeah, that's sort of what people are working on. People are trying to get them to model these probability distributions better and better. And in response, you'll just get better models. You'll get smarter models. So yeah, great question. Is it, can you do fine tuning on your own? Yes, you can. It's going to be expensive. And if you don't have computers that are big enough, you won't be able to. But if you do have computers that are big enough, then yes. GPT is way too big to fit on your computer, probably. So, but they have a fine tuning API. It's not available for ChatGPT yet, but it is available for GPT-3. So you can just search OpenAI fine tuning API, and you can fine tune your models with OpenAI. Can we use ChatGPT APIs on a different set of data instead of internet data? Yes. So you can try it. It might not work super well because there's a thing in machine learning called generalization, and it doesn't always happen. If you want to use it on data that it wasn't explicitly trained on, you have to be careful because it could just not understand that space very well. Okay, cool. Any other questions? Do you think AI will have consciousness? I'm gonna respectfully decline to answer that. It's too complicated of a question. Like, I don't even know how to define consciousness to start. And the smartest philosophers have debated about this for hundreds of years, and I don't expect them to stop. I feel like it's one of those unresolvable questions. It comes down to personal opinion. All right, let's start coding. Please follow along if you're able to. It'll be more fun, and I guess you'll probably learn more. What you want to do is you want to Google MIT App Inventor. And so you'll click the first link, and MIT App Inventor is this like really convenient application programming tool, and it's super nice. So what you want to do is you want to go to the top left and click Create Apps, and it'll ask you to sign in with your account. And so you can do that. And I'll start a new project. I'll call my new project ChatGPT. And so we're on ChatGPT. Drop an OK in the chat once you're here so that I know that everyone is ready. If you don't know what MIT App Inventor is, don't worry, you can follow along. If you have a little bit of experience programming, then you'll be fine. Sick. Okay, looks like a lot of people are here. Okay. Nice. So before we do any programming, we actually need to understand how the API works. So I will just do this part. You don't have to do this part because I'll just explain how it works. You can search OpenAI API and you can just get started. Let me think here. So I'm actually not super sure if OpenAI gives you free credits. Because I'm considering if they don't give you free credits, then I could give you guys my API key, but I just need to trust you guys not to abuse it. Oh, it gives you free credits for a trial. Amazing. Okay, so I'm gonna create a new account then. So I'm gonna follow along with you guys. Basically, you want to go to if you want to Google OpenAI API, and then you can click the first thing, it just says GPT-3 API, and then you can click Get Started. And so you need to create an account. I'll send this link to you guys, how to create an account. Copy link address, go to this link, make an account. So I will use my Google account that I don't actually have an OpenAI account with. You should sign into your Google account and you'll link it with your OpenAI API. Tell us about you. Kevin Meng is my name. I'm from MIT. Click continue. It's going to ask you to verify your phone number, so please do that. If you don't have a phone, please ask your parents and then type in the code that it texts you. So my code is 394,388. I'm exploring personal use. And so yeah, welcome to OpenAI. Awesome. Let me just double check that they give me credits. Manage account, billing. I'm on my free trial. My usage page, I get $5 of free credits. Amazing. That's more than enough. Cool. So once you have your account and you see this page, drop an OK in the chat, because then you're pretty much all set. I'll give people a moment to get this to work. Okay, yeah, don't worry, William. We'll wait up. App Inventor has to use Gmail or Google account. I believe so. They started as a Google project, so yeah. So in the meantime, while you guys are creating this thing, I'll just walk you guys through how the API works. Usually when you want to understand how an API works, you should just search up OpenAI API documentation, like just search up documentation. So click on the introduction. That's useless to me. We're going to go to the API reference. If you want to follow along, I'll put this link here. So the completions API is an API that can just, it's basically like the ChatGPT front end that we were playing with here, except that we were playing with here. It's basically this thing, except you can call it from MIT App Inventor. That's the really powerful part. You can integrate it into your application. So let's look at this. Has anyone not seen an API before? If you haven't, please type a no in the chat. Let me know in some way if you've never seen an API. Okay, so I'll briefly explain what an API is. This will be fast for the people who already know. If you're in tech bots, you should probably know. Just saying. This will be pretty simple. Let's see. Zoom. Great. So we're back to the whiteboard. APIs, super exciting. In anticipation of this, I've actually already copied it over the API request. So APIs. The point of an API, and API stands for application programming. There are two M's in programming. Interface. The point of an API is that there are certain tasks that you are not fit to do. If you wanted to know what the weather was, what would you do? Would you set up a weather station, get a thermometer, get a barometer, get an altitude sensor, get a wind direction sock thingy? No, you would simply ask the weatherman, right? But if if you had to email the weatherman or you had to go to his house to ask him what the weather was, that'd be really, really annoying. So what the weatherman has done is he set up this web server, he set up this website, and it's like free information. You can, instead of going to his house and asking him directly, you can go to this free website that this weatherman has set up and be like, yo, can I get the weather real quick? And because it's a website, it works really quickly and you just get the weather. So there's this weather.com. This is not just the weatherman. This is a company that has like thermometers and stuff. They have barometers, like wind socks. They have all these different measurement tools and stuff. So they know what the weather is. They know what the weather is. And so you're here and you're sad because you don't know what the weather is. But because weather.com has an API, there's an API here somewhere, you can ask, what's the weather? And it'll return to you, it's 85 degrees Fahrenheit in, I don't know, Sydney. And so this exchange is what's called, it's called, I don't know what it's called. It's called like a communication with the server. But the point is the API is able to field your question. It's able to receive your question, and it's able to transmit the response back, receive the question and transmit the response back. And so, extremely powerful. You personally don't know how to implement something as large scale as ChatGPT, but OpenAI has done it for you, and they just charge you a little bit of money every time you use it. That's the point of an API. It's for someone else to perform or operate a service that is too complicated for you to operate, and then you can simply just ask them for the service and you just pay for it. Make sense? Okay, I don't see any questions. Probably a good thing. And so let's break down the anatomy of an API request. So don't worry about this curl thing, not relevant. But this is a website, or it's a URL. It's an HTTPS location somewhere in the cloud. This is like their address. It's like if you wanted to go to the weatherman and you wanted to ask him what the weather was, this is his address. You need to know where to go to ask your question. And then here you specify some stuff. You specify that there's a certain model that you want. OpenAI has a bunch of different GPT models. Some GPT models are small and some of them are big. Some of them are smart and some of them are stupid. We're going to use the best one. This GPT-3.5-turbo, this simply just means ChatGPT. It's the official technical name for it in their API. And then so the messages would be, hello, from a user. We'll talk a little bit more about what this means, this whole role and user thing means. But for now, all you have to know is that you can send it a message. You can say hello. Or maybe instead of hello, you could say, what team does, I'm just going to abbreviate it, is it LeBron James play for? And this is like sort of the message that you send. This thing right here corresponds to this arrow. This is the message that you send, right? And then somehow, eventually, OpenAI is going to come back to you and they're going to say, oh, well, he plays football. Or no, sorry, he plays basketball. OpenAI is going to respond with this. Now, there's some other stuff in this request that I haven't talked about. There's this like menacing looking your API key. Basically, you have to identify yourself to the API. Like if you're not paying for the service, OpenAI doesn't want to answer your question. And so the API key ties this request to you. And so if you're paying, then OpenAI is happy and they can charge you, target your billing account. And if you're not paying, then they can deny the request. It's simply just a way of like logging or tying the requests to you. Also, so that if you do anything illegal, then OpenAI can blame it on you. Pretty simple. And then there's this other header that says content type. All it does is it indicates to the OpenAI API that that you're about to get a JSON. And what's a JSON? It's just simply a way of formatting data. And if you've seen JSON before, this blue box right here that I've highlighted, or now I'm highlighting it in red, this is a JSON formatted message. It's just basically there's a key and there's a value and they're connected by 2 dots, the colon. It's just a key value store. So yeah, that's it. That's an API. So now that you understand what an API is, we can start doing more stuff. So let's go back to our MIT App Inventor thing. Oh, what did I do? Let's go back to MIT App Inventor and let's design an interface. Can you share the JSON to the chat box? Yes, sure. I can, but you don't have to use it. But in case if you want to play with it, then sure. Here, oh. Where did I get this thing? Well, this isn't ChatGPT actually. Wait, chat. Oh, chat. There it is. I'm blind. Here, there you go. But yeah, so now we can design. Let's go ahead and design our interface and worry about this chat thing later. We can design our interface to look. We can basically try to recreate this interface. And you don't have to. You can. The amazing thing about ChatGPT is that you don't have to use it as a chatbot. You can ask it questions and have it do things for you. Let me give you an example. I'm reading this book in my college lit class, and there's like a chapter that maybe I haven't read before class. You can just take this thing and copy it into ChatGPT, and you can ask it, read this passage. Question, what is a 2-line summary? Oh, well, it's already giving me the continuation. Basically, it summarizes it for me, and you can ask different questions. And so you can, you could even build like an MIT App Inventor app that does your homework. But today we're just going to build a chatbot because it's the most intuitive thing and it can probably most easily explain like what is important. Yeah, let's build our chatbot. So we have to somehow, let's have a label. And this label will just continue a log, or just will have a log of the conversation. So let's say conversation log goes here. And we also need a text box, right? Because we need to type in our prompt. And the text would just be like, hello. Oh, no. The text would just be blank for now. But the hint would be type your message here. And then we should have a button. The button will help people. The button will, we can put this like send to OpenAI. To make this nice, we're going to set the width to fill the parent. We're going to set this width to fill the parent. We're going to make this width fill the parent and also fill the height. This is the conversation log. So what does this actually look like? Well, let me connect it to my phone real quick. So if you'll excuse me, I'm gonna cast my phone to the computer so that you can see what I'm doing. Hopefully. AirDroid cast. So I'm going to project my phone. Oh yeah, sorry. I forgot that some of you guys haven't seen App Inventor before. So the point is that you can drag different UI components onto the screen. And so what did we need? We need a label, which is just a text display, just displays the text. We need the label to display the conversation that's currently going on. We need a button to click when we want to send our message to OpenAI. And we also need a text box. A text box is a text input. And so you need to you need the text box so that you can type your message. And so you need to you can take each of these components, you can drag it in. I'm going to delete this because I already have it, but you can just drag all these components in. And then if you want to resize stuff, you can go to the right-hand side. These are the properties of every single user interface element. And if you want this to be super pretty and you want it to fill the parent, the height, just to make the maximum height, you can just change this operation to, instead of be automatic, you should just fill the parent. Cool. Hopefully that's clear, and I can now show you what's going on. This is my phone. What am I doing? Okay, so this is my phone. Welcome to my phone. So what I need to do is I go to connect and I hit AI companion, and it gives me a QR code. And then so on my phone, I'm just going to scan the QR code. Uh-oh, what just happened? I think it glitched. Yeah, so App Inventor is not the brightest thing ever. Hard reset. Wait, no. Reset connection. So I can click scan QR code and then have it connect. Apologies about the technical difficulties. This thing is lagging. Okay, cool. So it looks like I fixed it, but now the AirDroid is broken. Okay, guys, bear with me. Sorry, this always happens. Oh, lots of connection error. Okay, quit. Yes, please quit. And now let's start it again. Ignore, start casting. Excellent. This should work soon. Okay, thank God. All right, amazing. So this is what it looks like. So we have the conversation log at the top, and then we can type our message here. Hello, hello, hello. When I click this button, nothing is going to happen because, well, we haven't programmed any logic yet. So we're going to do that soon. But yeah. So if you're at this stage, type in okay, or if you have questions, let me know. Okay, awesome. So now we have to program some logic. If you haven't used MIT App Inventor before, well, you have the front end, now you need the back end. You go to the top right and you can click blocks. You were originally on designer, click blocks. This is the code. It's really simple. For Ryan, on your phone, the text box doesn't show up. That's really strange. It should. Oh, if you're on an iPhone, it doesn't actually show up. You have to kind of click in the area and you'll realize that the text box is actually there. So click on the very far left where there's like a weird space, and you should realize that there is a text box. It just doesn't render very well because it's an iPhone, and MIT Inventor is not really well supported for iPhone. Can you repeat what you just did? Yeah, so you can click blocks. And you just click blocks. That's it. So now we're here. All right, so we have to say, we have to create a callback for the button. So like when the button is clicked, what do you do? And I actually forgot about something. You need to be able to interact with the web, because the whole point of an API is that you go to an internet address. So come to the left and scroll down. You'll want to scroll down to connectivity, and then there's this web component here. Take this and drag it onto the screen, and it'll show up at the bottom as a non-visible component. Because it's not a visible component, it's sort of working in the background, but it doesn't really matter. So there's a non-visible component, web. Now you go back to blocks. And if you click on web, you can see that you can make a post request. So the formal like language for how you send a request to an API is you post something. So when you create a post request, you just, I think you, where is it? Post text. And so this will basically send a request to the server. But if you remember, there's this thing, there are a few headers that need to be instantiated. You need to specify the content type and the authorization. You need to copy your API key in. So to specify a header in MIT App Inventor, you can go to this web thing, and you can go down to sets, and you can set the request headers. And the way that the request headers is formatted is it's a list of the headers. So you can come down to lists and create a list. And because we have two headers, we'll want two lists. But then every single one will be another list. It's kind of like list inception, because remember, there are two different headers that we want. I'll just screenshot it and put it here. Oh no, what did I just do? We're gonna screenshot this and open it. Okay, so we have content type is a header that we want, and then authorization is one that we want. So in the list, you want to type content type. That's the key, and then we duplicate this and set this as authorization. Basically, what this indicates is like what comes next is the content type, and what comes next is the authorization. So the content type will be application/JSON. This is just API speak for we're going to send you a JSON formatted thing. And the authorization, we want to have it in this format. So capital bearer, and then you want to copy your API key in. I'll leave this blank and I'll fill it in later. And I'll pause for a moment because I'm happy to help with any App Inventor related questions. So for people who are new to App Inventor, the principle is that any component on the left-hand side will have a bunch of methods. We'll have a bunch of functions that you can call. And what we're currently doing is we're setting a callback for this button. So when the button is clicked, you will send a request to the API server. Well, how do you send this request? Well, first of all, you saw in the API documentation that you need to set request headers. It's kind of like metadata. You need to identify yourself and indicate what you're going to send to the server. So we need to set the request headers. To access this, go to the very left and click Web 1 and scroll to the bottom until you see request headers. Drag it out. That sets the headers. MIT App Inventor expects the headers in a list of lists. What this means is that for every single header, it's a list element, and then for every single header, you need to concatenate the tag or the key of the header and the content. So to create a list, you go to the very, very left and click lists, scroll to the very top and click make a list and drag it out. If you don't see web, it's because you didn't drag it in. So you need to go back to the designer. So the top left or in the top right, there's the left-hand button designer. And then you go to connectivity. by default, you're going to be at user interface. So scroll down and go to connectivity, and there's going to be a web thing. Drag it in, and then you'll see web 1. Cool. How to create the very first block? Excellent question. Well, in principle, if a block is tied to a certain component, then go to that component. So at the very left, you can see that the button is right here. So if you click on it, you'll see that the first thing that shows up is the callback. I'll give people a few moments to do this. So to get text, you go to the very left and you click text, and then you click the first thing, then you drag it out, then you click in the middle and you can type whatever you want. If you're okay with this, drop an okay in the chat, and then if you have further questions, feel free to let me know. Amazing. Okay, so we're doing good. Zoe, no worries. Is there a specific question that I can help you with, or do you just want me to walk you through the entire thing again? For things that you don't understand, is it because you don't understand where to get the blocks, or is it because you don't understand why we're doing what we're doing? Cool. So which one do you want to know how to get? Oh, the first one. So you go to the very left and you click button, and it's the first one there. So in general, like if you want, you can, a general rule for finding blocks is like, if you want to perform a certain action on a component, whether it's a label or a text box or a button, you should go to the left and look for that component. And so if we want to say, well, when the button is clicked, what happens? Well, there's usually a callback in that button to define what happens. So you can drag this out. Cool. You know, it looks like there's a little bit of confusion, so let me just redo the entire thing. No worries, it happens. And I apologize for going too fast. So, first principles. When you want to do something, always go to the relevant block and look for the block. That'll answer 99% of your questions. So, for the people who who want me to go again, would you mind telling me what's the first step? If I have an interface like this, what should I do? Like, what's the main problem? What is wrong with this interface that I have right here? Any thoughts? Exactly. You don't do anything after you click the button. So that's your first clue. What do I need to do? Well, I need to find a block that will call some code whenever I press the button. So you know that it has to do with the button, so you can go to the blocks section and you can say, well, let me click on the button. Are there any relevant functions here that deal with clicking stuff? And if you scroll around, eventually you'll realize that the first thing is a callback, and it will activate whenever the button is clicked. So when button.click, do something, right? So what do I need to do when I click the button? Does anyone want to kind of outline the different steps that I need to make? Exactly. I need to get the text and then send it to someone. Well, we talked about the API, and the API requires just a little bit of setup, because you need to inform what content is being sent and what the authorization key is, your identity. So what you need to do then is, well, think, how do I call the web API? I might need to use the web component. And so if you go to the web component, you'll find, if you scroll around, you'll see that the first thing that you need to do is to set the headers. And if you scroll to the very bottom, there's this thing called set web1.request headers. You can drag it out, and that's the first thing you need to do. Right? So let's do one thing at a time. One request header is a key and a value. The way that we're going to encode this is with a list. The first element of the list will be the key, and the second element will be the value. Let's try to encode content type first. Content type is the key, and application/JSON is the value. So to make a list, go to the very left, click lists, and then go to the second element, drag it out, make a list. And once you make a list, you can go to the text on the very left, drag out the first thing, and you can write the key in here, content-type. And then you can do this again, go to the left, click text, drag it out, and then type application/JSON. And so you need to do this, then you need to make another list because we have two different headers. We have another one. Jonas, maybe, I'm not super sure. This is how I've always done things with MIT App Inventor, but I guess it's possible that maybe it works. I'm not really sure. So for the second one, you need to type authorization. And then the value will be bearer and then your API key. And so you need to figure out what your API key is. To do that, you'll need to go to the OpenAI dashboard. So I'll show you guys the link. I'll send it to you guys, in fact. If you're logged in, this link should work for you. You should go to this link, and you'll have a secret key, or you won't have a secret key. Let me create one. And you need to copy this. Make sure that you copy it. Don't lose it, because you're not going to get another one of these. Or well, you can generate a new one, but this one will never show up again. So make sure you copy it, and then go back to MIT App Inventor and paste it right after bearer. So it should look something like this. Once you have that done, you should put these into a list and then stick them in the request headers. For Zoe, is it like you don't know how to get it, or do you not know why we're doing this? Yeah, I'm happy to do the API key again. So go to this link. Oh, shoot, that's my API key. Go to this link, and there will be a button that says create new secret key. Click create new secret key, and then click the green button. This copies the API key. And once you've copied it, you can go back to the code, and then you can paste it right after bearer. So it'll look like this: bearer space and then paste. It will generate different keys every time you click it. Yes. So you can have an unlimited number of API keys. Like if you're going to give your friend access to your account, you could give them a new API key. And then what you can do is you can delete it whenever they're finished with whatever they're doing on your account, so that you know that they're not abusing your account in the future or something like that. For Amanda, you follow the link. So go to this link, and then you can click create new secret key. Cool. Any further questions? These are excellent questions. Even if MIT App Inventor is a little bit new to you, hopefully it makes sense. I mean, it's just another programming environment. I'm happy to let people open their mic if they want. It's fine. Okay, if there are no more questions, we're going to move on to the next part, which is once you have this request header stuff together, what are you going to post? So we need to make the post request. And so we can go to web 1 and scroll down, and there's a function that says call post text. You want to drag that out. This will actually send the request to the API server. Should different APIs use different keys? Yes, every API service will have their own key system. So you post the text. Well, what is this text supposed to look like? Well, we saw earlier that you can that there's this JSON thing. It looks like this. I'll send it in the chat. This will send a request that says hello to the GPT 3.5 turbo model. So what you can actually do right now, let's just ignore what the user has typed. Let's just test our API. Let's just make sure that it works. And so we can create a new text box, go to the left, click text, scroll up, pull a new text box out, and then paste this in. Just paste it in. And so this will allow you to get a response. Your web doesn't show posts. You'll just have to look a little bit closer. So if you scroll down slowly, you'll see that there's patch, there's post, there's put, there's encode, decode. Oh, yours only shows delete. I don't even see a delete here. Make sure that it looks like this globe looking thing. It's web. Okay, awesome. Thanks. Yeah, no worries. Happens. For William, who says you can't copy it, yeah. So there's another option, which is you can go to this link and you can copy this, or you can just type it in. Here, I'll type it in with you. I will type it in alongside you guys. So here's what we need to type. Let me delete it and let's type it. Open close bracket. Make sure you have the close bracket. Open close parentheses. Role : user. Everyone good with this? Now you want the second element of the JSON. Put a comma. Open close quotes, content. Colon, hello, exclamation mark. So this is the message that you want to send to it. You need to put a straight bracket at the very end and a straight bracket at the very beginning because you need to send a list of messages. We're just going to send one for now. All right. Straight bracket at the beginning, straight bracket at the end, open close parentheses, type messages, hit colon. This gives you the messages. Now, you need to specify the messages, but you also need to specify the model. So now you can open close parentheses and type model, colon, open close parentheses, GPT-3.5 comma. This indicates that the first term is model. And the second term is messages, and it should look like this. Be very careful, because if you type it in incorrectly, your thing won't work. And unfortunately, there's not much I can do about that. And finally, open curly bracket at the very, very beginning, and then scroll to the very, 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 very end, and then close the bracket. Congratulations, you just have written JSON. Yeah, so here. All right, so classes, we're a little bit short on time, so I'm going to, hopefully this makes sense. Now I'm going to test it. Here's my phone. There's one thing that we haven't taken care of, which is once you send the post request, OpenAI will receive and process it. But then once it sends information back to you, you need to actually intercept that information. So how can we do that? Well, again, it concerns the web. So let's go back to the web component. The web component has, if you scroll around, at the very top, there's this thing called got text. It's basically something that is a function that is called whenever the server sends information back to you. And just for the sake of testing, let's just set the label text. So you go on the very left to label, scroll down, you set the label text to the response content. So you hover over this thing and then you just drag it up. So what should happen now, and I'll give people a few moments to catch up, don't worry, I'm not moving on. What should happen now is whenever I click this button on the right that says send to OpenAI, let's track the code. The request headers are set to the appropriate thing, and then we post this message, and then hopefully the OpenAI model will do all its fancy probability stuff, and then it'll send the response back to us. Let's see what happens. I click send to OpenAI, and nothing happens. It's probably because my MIT App Inventor isn't updated. So let's refresh it. Connect to AI Companion, scan QR code. It'll take a moment. I should click send. Oh, I forgot to set the URL. That's pretty funny. Okay, so at the very left, you should click web again, and then go down to set website URL. Because guess what? I forgot to tell my computer where to ask for the information. That's pretty funny. So you need to go to this URL. It's right here. I'll copy it, put it in the chat. Please copy it for yourself if you can't copy the chat. But it's pretty simple. It's just an OpenAI endpoint. https://api.openai.com/v1/chat/completions. And so this will tell it you should go to this URL to send this data. Let's try it again. I hit this, and then it says incorrect API key provided. Oh no. I might have deleted my API key. So if that happens to you, what you want to do is just kind of delete everything, generate a new key, copy it, and get a new key if your key ever is marked as invalid. So I'm going to copy my new key over, and hopefully this will work. Send to OpenAI. Awesome. So we get a response. And what is the response? Well, the message that we got back was, hi there, how can I assist you today? Very cool. So there's the results. But as you can see, it's a pretty complicated result. Like there's a lot going on. We need to parse it somehow. So I know we're running up against the clock. So if it's okay with you guys, I'm going to speed through the rest of this just to make sure that you can see what eventually happens. And if it's not clear, if anything is not clear to you, we will be publishing the I'll be publishing the final code on the gallery, and you can play with it. And if you're interested, if MIT App Inventor seems like a cool concept to you, then I recommend you sign up for the class and you can find out how to use it. So, and I'll be explaining technically what I'm doing, and it's okay if you're not able to follow along, but if you can, that's amazing. So this is what we call JSON, and we need to parse it. So what we need to do is we need to come to dictionaries, or I think there's a web component for this. JSON text decode with dictionaries. So we're going to take this JSON and we're going to decode it into a dictionary. And then in this dictionary, we're going to try to get a key, get value for key in dictionary. This is our dictionary. And the key that we want is ID object created choices. It's called choices. Choices. And so we have choices, but choices is yet another, it's a list. So then we need to get the 0th element of the list. So select list item, this is the list, and the index is going to be 0. And finally, there's this thing called message. And then there's content. Okay, so there's 2 more dictionaries. Then I need to get the value for the key again in this dictionary. And it's, oh, I seem to have forgotten the key. The key is message. So message, no more messages, it's message. And finally, dictionaries, get value for key in dictionary. This will be content. Ooh, okay. So this should be the content. So actually, if I substitute this for whatever that was, and I click this button, oh no, it's broken. So choices is a list, select list item list 0. Oh, okay. So MIT App Inventor is 1 index. I forgot about that. So in programming languages, usually 0 is the first index, but in MIT App Inventor 1 is the first index. So there you go. It says, hello there. How may I assist you today? Unfortunately, we didn't program any logic for this chatbot to read anything from our text box. So we should probably do that. And we should also probably add to the text log so that, we can remember what we said. So what I'm going to do is I'm going to come back to this label and I'm going to set its text. The first thing we should do before we even deal with any web stuff is to set the text to the join, which is just a combined text. We're basically appending to the log. We'll join what the current text box or the current label text is. We'll get the text. And maybe we'll make it fancy. We'll be like user : and we're going to append another string, and then we're gonna, you know what, we'll just leave it at that. And then once we get the output, we should append to the label again. So instead of doing this setting, we will say, okay, well, ChatGPT : and so now it'll append. So what I also need to do is set some returns. We need to get the label text. I need to get the label text. And this is actually not correct. We need to put the label text here and then append the text box information. We will append the text. And then so this is supposed to append it to the log. So like if I ever type this, send to OpenAI. Oh, I also need to do that. Okay, so now when I click, it's going to give me a bunch of like, it's going to give me, it's going to put this in the log. The user has said this, and then I'll also do the same thing here. So now the only thing that remains to be done is to customize this message. So instead of always passing in hello, we should pass in our chat log. Let's just pass in our chat log, right? So I'm going to split it right here and use another join. And I'm going to say, here's the beginning. Here's the end. And what goes in the middle? Well, the label one.txt goes in the middle. All right, so let me refresh the screen and see what happens. So the conversation log goes here. how are you doing today? Is my question, and I send it to OpenAI, and it's great. So something has gone wrong. It looks like OpenAI is not happy with me. I might have made too many requests. And so there is there's something you can do, which is whenever you're encountering errors in your code, you should print stuff out. And so instead of doing this label one.txt, we can simply just get the response code. No, we should print the response content. So let's print the response content. We could not parse the JSON body of your request. Oh, interesting. Okay, so it's not happy. Whenever this happens, you should again try to debug what's going on. So let's set the label text to the text that we're passing in. Hopefully this will explain the problem. So when I click, how are you doing today? It's going to send, oh. Okay, well, refresh. When I type something in, what is it going to send to OpenAI? It sends this. Conversation log goes here, and then there's a bunch of stuff. This looks correct to me. I'm not sure what the problem is. Not totally sure. And it didn't quite error. Yeah, so the line break. Oh, wait, did I not remove that? No, I did. The line break should not be a problem. Huh. Interesting. Okay, well, there is one thing that we can do, which is to avoid line breaks for now by putting this in there instead. Instead of the label, we'll just do the text box. And there you go. ChatGPT says, I'm sorry, I don't understand what's going on. So let me refresh and explain what I just did. It looks like line breaks, the JSON does not actually like very well. This isn't true in the real world. Like this is probably some limitation that we could overcome if we had a little bit more time. But apparently this API doesn't like line breaks. I think it's due to how text is parsed in MIT App Inventor. Line breaks are generally okay in JSON. And so what I can do is I can say, I can even ask the same question. What team does LeBron James play for? Send to OpenAI. And it says LeBron James currently plays for the LA Lakers. And so I'll delete my debugging text so that it's a little bit nicer. You can say, write me a poem about a poem about watermelons and how delicious they are. Send to OpenAI. And if you give it a moment, it'll say, oh, watermelons, sweet and juicy, summer's most delightful treat, blah, blah, blah. So it's pretty neat. You can talk to ChatGPT from within App Inventor. And the point is that you don't have to make it a chatbot. You can have it do your homework, answer questions, all these incredible, cool things. And the power is sort of in your hands. There you go. So we're done. I apologize for the speed run at the very end. It's kind of hard to reconcile like a bunch of ranging experience levels with MIT App Inventor. But I hope that this was insightful in the sense that you've gotten a deeper look at how GPT works in terms of the machine learning model and what it does behind the scenes. I hope you found that it's actually more intuitive and more accessible than you thought it was. And then finally, hopefully this final part showed you how easy it can be to integrate an incredibly complicated feat of engineering. Truly, like ChatGPT is a marvel of engineering. How easy it can be to integrate one of those things with your MIT App Inventor app, something that you can basically use to create apps within days of learning how to code. So Yeah, cool. So I will scroll up, sure, or I'll just make this smaller. And I will also publish to the gallery. So let me pause this screen sharing and then I can publish to the gallery and send you guys the link. ChatGPT, this is, oh, I'm gonna delete my secret key. That's probably smart. Oh, what the? API key here. And I'll publish this to the gallery. So ChatGPT wrapper, and then image file. I will just choose a random image. Desktop. Download. Submit. My apps. ChatGPT permalink. Copy. And so there you go. There's the gallery link. So some questions. Is it possible to deploy this project to my phone as a real app? Yes, indeed. If you go to the top left and you click build, you can build an Android app. And this is an app that you can publish on the App Store. It's something that you can send to your friends and have them install on their phone. And you can pretty much do whatever you want with it. Pretty exciting. What's an example of a real life application and of an API? Well, for Kevin, this is a real life example. If you go on Twitter and you search like ChatGPT products, like you will find a gigaton of them. So a bunch of people are building massive companies around ChatGPT. They're building like legal search. They're building there's a lot of value being created around this kind of stuff. And that's all like API based. Weather APIs are super important. When you go to Google Maps and you ask it how to get to the airport or get to your favorite chicken wing place, like it uses an API. APIs are everywhere. It's basically just, the point is that if you have a service that other people find it hard to create for themselves, they'll pay for you to use your service. So they're ubiquitous. What scenario can ChatGPT be used for? I mean, a lot of things. It's pretty insane. Like if you just Google things ChatGPT can do, you can just read some of these documents. There's some pretty clever things. You can even help, you can make it help you study. So if I go to the Times and, when I was in high school, our teachers made us do this thing where you would like read an article and they would quiz you questions on it because they wanted to make sure that you were keeping up with current events. So one thing that the kids used to do was we made flashcards for these articles. Like we would pick out all the things that you could ask about and then make flashcards so that we could memorize them because, obviously we wanted to do well. Okay, so then I could go to ChatGPT and say, instead of like me reading the article and having to come up with questions myself, I could just say, read this document and generate 10 questions to quiz me on it. And you can just paste this in. Ah, shoot. An error occurred. I'm crying. Okay, so maybe ChatGPT is down or like it doesn't like me. Let me make it shorter. Well, it's probably too long, but anyways, you get to the point. If I just had a short, article like this, generate, let's say 5 questions. Okay, yeah, never mind. OpenAI is down. That's really sad, but whatever. Yeah. Yeah, so ChatGPT has limits for free users, but I'm not a free user. I pay for it. So, oh no, I don't. This is the free preview. So yeah, if you go to the yeah, you can pay like $20 a month for the pro version, or you can just use the API as I usually do. Will the API request be sent to MIT App Inventor or ChatGPT? Great question. It's sent to OpenAI ChatGPT. Do I think the plus version is worth it? Probably not. I don't personally use ChatGPT that often. It's just not good for what I want to use it for, but some people are really enthusiastic about paying for it because it's really useful for them. For Henry, the API key can be found. Oh, thanks so much, Isaac. You just go to that link and then you click create a secret. So if I click on it, you can just see create a new secret key. Okay. All right, we're about 15 minutes over time, but thank you so much for coming out. Really appreciate it. Hope that this was interesting. Don't worry if not everything made sense, because the more you're exposed to this kind of stuff, the more you'll learn. And yeah, it's been great. Good luck with school. Good luck with stuff. Take care.